Okay, so we'll be continuing now on our discussion on polar coordinates. Okay, so this is the second part of the video lecture series on polar coordinates. Okay, so today's for this topic we will be starting with polar graphs. Okay, so aside from transforming the rectangular coordinate of a particular point into polar coordinates, we could also transform the equation of a particular locus to its polar coordinate counterpart. Consider the line ax plus by equals c in rectangular coordinate. Converting it into a polar equation, we have, remember our substitution, x is equal to r cosine theta, while y is equal to r sine theta. If we're going to replace x with r cosine theta and y with r sine theta, then our equation ax plus by equals c becomes c is equal to ar cosine theta plus b r sine theta. And since r is a common factor, we could bring that out in the equation, so we can have c is equal to r a cosine theta plus b sine theta. Now, of course, the condition here is that c should not be equal to 0, otherwise um, our um, our equation would simply fall into a point. Now, of course, if c is equal to 0, r is equal to 0, that means you will not have any form of a graph. Now, if c is 0, it's either r is 0 or a cosine theta plus b sine theta is equal to 0, which which means if a cosine theta plus b sine theta is equal to 0, we could actually transpose one of the term to the other side. Doing that, we have a cosine theta is equal to negative b sine theta. Solving for cosine over sine, that gives us negative b over a. Okay, so so this is another typographical error. Consider revising the your notes in this course where, okay, so again, a cosine theta plus b sine theta is equal to 0. Transpose the one of the terms to the other side, so that becomes negative b sine theta. If we're going to solve for sine over cosine, okay, sine over cosine, so that means you have a over negative b as your sine over cosine. Okay? Remember, our definition for tangent theta is sine over cosine. So that means if the objective here is to solve for tangent theta, that means we need to solve for sine over cosine. And from this relationship, sine over cosine has the ratio a over negative b. Okay, so let's try to prove that again. The tangent theta is indeed sine over cosine. It is represented above in the first video lecture that we have the definition of tangent as y over x. Okay, so since y is remember, our y is equal to r sine theta and x is equal to r cosine theta. So that means our definition for tangent is equal to sine over cosine, which is y over x. That is why the formula for the inverse tangent is y over x. So if you're going to compute for theta, tangent theta is simply y over x, and y is equal to r sine theta, and x is equal to r cosine theta. So therefore, tangent theta is sine theta over cosine theta. So dividing x from y, we have y over x is equal to, remember, this is wrong. Remember, y is equal to r sine theta, just like what we see here. So y here is in the numerator. So therefore, r sine theta should be in the numerator, and x here is r cosine theta, and x here is in the denominator. So that means r cosine theta should be in the denominator. Okay, so therefore, if we r is cancelled here, um, the tangent theta should be defined as a sine over cosine. Okay, so let's try to prove that using an alternate source. Let's try to Google the result. Um, Trigonometric identity identity for tangent. Okay, so let's try this one. Okay, so the idea here is to provide proof that indeed tangent is the ratio of sine over cosine. Okay, so as you can see here, tangent x, which represents the angle, is defined as sine x over cosine x. Okay, so tangent is indeed sine over cosine. So what we see here in our courseware here, this is actually wrong. So tangent theta is defined as y over x, and y is r sine theta, and x is equal to r cosine theta. So therefore, if simply cancel r, so what should be left here should be tangent theta is equal to sine over cosine. Okay, so going back to our example for the polar graph, so what we see here is that if we're going to solve for tangent, tangent should be sine over cosine, so that is a over negative b. So arc tangent is actually negative a over b, or a over negative b, or simply negative b a over b. Now, since b and a are just constants, we therefore have theta is equal to c. Okay, so at the same time, we could also convert an equation from polar to rectangular. Consider the circle r is equal to 2 cosine theta in polar coordinates. Converting it into a rectangular equation, we have r is equal to 2 cosine theta. If we're going to multiply both sides by r, that becomes r squared is equal to 2r cosine theta. Now remember, r cosine theta gives us our x. So remember, r cosine theta above is defined as x, so this becomes 2x, and this becomes r squared. And remember, r squared is given as x squared plus y squared. Now, if we're going to transpose 2x to the side of to the left side, this becomes 2 x squared minus 2x plus y squared is equal to 0. Now, trying to introduce the unit circle, the circle that has radius equal to 1. So therefore, if we're going to introduce a 1 factor or 1 addend here on both sides, uh, literally introducing one, but it doesn't necessarily that we introduced one, is that we have changed the value, the overall value of the equation. We still have the overall value as equal to 0. We just introduced one, since we could always cancel one here, but for the purpose of introducing the radius of the circle equal to 1, we have introduced 1 on both sides of the equal sign. So we have x squared minus 2x plus 1 plus y squared is equal to 1. Now remember, 2x squared minus 2x plus 1 can be factored using special products as equal to x minus 1 squared, then plus y squared is equal to 1. The resulting rectangular equation is still a circle in rectangular coordinates. Moreover, it is a circle with radius 1, and it has the center located at negative at 1 and 0. Remember, your in our discussion of the circle in our video lecture series on circles, the basic form of the equation of the circle is has the form x minus h square plus y minus k square is equal to r square. So that means this is actually our h, and this is the, since this has no k, the value of k is equal to 0, obviously, and our hk ordered pair corresponds to 1 and 0. So the location of the center of this circle is 1, 0, and its radius is equal to 1. Okay, so the idea here, in order to convert an equation in polar form, is to achieve the form of the equation in the form of x squared plus y squared. If you're given r, we need to introduce r so that we can have r squared, so that we will have a pair for either sine or cosine and represent that portion as x or y. Okay, note that changing coordinates does not change geometric properties of the points and the loci. In particular, the distance between points doesn't change, hence circles in rectangular coordinates stay circle in polar coordinates and vice versa. This also implies that the equation of a line in polar coordinates is either r is equal to c over a cosine theta plus b sine theta, or simply theta is equal to c. Now, I will not be presenting to you the following examples. I'll be asking you to do this as part of your exercises. Convert the following rectangular equations in polar equation, and this will also be submitted on Friday. Okay?